So far, most of our programs have been straightforward. The program is started, execution occurs, and then the program ends naturally. But most programs that you use every day are not like that. You start the program, a window appears, and then the program waits for you to do something. Each time you click a button or type some text or scroll with your mouse, the program reacts in an appropriate way. These input events trigger output, and the program allows you to do these interactions as much as you like. The web browser you are using right now is a great example of a program like this. You can keep scrolling and clicking and typing until eventually you close the program. Mastering this new model will greatly enhance the kinds of programs that we can build. We will build these programs using Designer. Designer uses an event-driven model to handle interactivity. Designer provides a function named when that can take in the name of an event and a function name to execute when that event occurs. Notice we said a function name. This is a serious departure from all functions we have seen so far, which have not taken in a function. Some functions can take in the result of calling a function, but that is very different from a function name. Specifically, a function call is a function's name followed by parentheses. That executes the function immediately and returns a new value depending on the return type of the function. But now, without the parentheses, we are actually using the function as a value directly. The reason for this is that Designer will call that function on our behalf later. In this example, we are binding the spin function to the updating event. When a function is bound with the when function, Designer will essentially wrap that function call in an if statement. When the named event is active, the function is called. Each type of event has different logic for when that event is active, corresponding to the conditional of an if statement. The body of the if statement is basically the body of the bound function. So, what is happening in these bound functions? Previously, we learned how to use the designer library to draw pictures, and how we could even make functions that drew pictures in a reusable way by returning designer objects. These bound functions, however, are completely different. Now, the function consumes a designer object in order to manipulate the object. But where does that designer object come from? The answer is the new start function, which is exactly like draw, but allows the program to keep running so that it can accept interactive events. That start function accepts an initial state for the game, in this case, an emoji of a pie. That emoji becomes the state parameter for the bound function, passed in as an argument every time the game updates, so that the bound function can mess with the current version. But what do we mean by every time the game updates? Watching an animated movie, characters appear to be moving around, but if you pause the movie, then suddenly they are fixed in place. If you advanced forward one step, you would see that the character has moved to a new position, close to their old one. When you press play, the next set of frozen images are shown, each one moving the character forward just a little bit more. Because the sequence of images are played in rapid succession, the characters appear to be moving. Games update in a similar way, with each step of the game simply having the game objects in a new location close to their old one. In most games, this happens many times a second, based on the frame rate of the game. In a 30 frames per second game, the updates happen 30 times a second. So if you wanted to move a pie across a screen that was 300 pixels long in 10 seconds, you would need to move 1 pixel per step. If you wanted to have the pie reach the edge of the screen in 5 seconds, you would only need to have it move 2 pixels per step. One of the most confusing aspects of the game is the state parameter. Let's return to the idea of the pie moving across the screen frame by frame. If we once again pause the execution after a little while, we would see the pie frozen in one place. We can then talk about the current state of the pie. In Designer, that state is provided as a parameter to any bound function, specifically the first parameter. Almost certainly, any bound function will want to manipulate that parameter using the built-in designer functions. Typically, they will only make a very small change, a minor rotation, a small movement, that sort of thing. Besides the updating event, there are two other events we will talk about. First is the typing event, which occurs when you press on the keyboard. Any function bound to the event will fire. That function takes a second additional parameter named key, which will be a string representing the name of the keyboard key pressed. For instance, the space key or the L key or the left arrow key. You can imagine how you might use this to implement a game where you can control your character to move them around. Here, we control whether the pie rotates left or right. This time, our move right is bound to the clicking event, which occurs when a mouse click occurs anywhere on the game window. In addition to the pie parameter representing the current state of the game, we also get two new parameters, the x and y of the mouse. We can use this to reposition the pie on top of the mouse. There are a few other kinds of events in Designer, but these three should be enough to let us make some interesting little games.